Hi everyone. So, machine learning as a technical discipline is not an isolated field coming from the void, but as you can guess, it's framed inside a wider domain that's artificial intelligence. So, as a discipline, it has its predecessor and it has been evolving in stages of increasing efficiency and increasing complexity. And the following, we can say, four clearly differential steps. So, the first model of machine learning involved a simple level of data-based algorithm that includes in itself, it includes in the algorithm all the possible ramifications, all the possible choices and decision rules that the machine should be aware of and should take, implying that all the possible option all the possible options will be programmed, will be edited, will be hard coded into the model beforehand by software engineer, by an expert in the field, in the domain. This structure was implemented in the majority of applications developed since the first programming languages appeared in the 1950. C++, Fortran, C, COBOL, Python. So here we should teach the machine that depending on if a condition were fulfilled, it must take a decision or another. During the second development stage of statistical reasoning, we started to let the probabilistic characteristics of the data, we let them have a say. So in addition to the previous choices that we hard-coded into the machine in advance, this better reflects the fuzzy nature of real-world problems where outliers data are common, and this discipline adds to the mix of mathematical tools elements of Bayesian the Bayesian probability theory. Methods pertaining to this category include curve fitting, usually linear or multilinear regressions, which has the common property of working with numerical data. The machine learning stage is the realm in which we are going to be working with in biology or in toxicology and in general in chemical risk assessment. It involves more complex tasks than the simplest Bayesian elements of the previous stage. And the most outstanding feature of machine learning algorithm is that they can generalize models from data, but the models are capable of generating their own feature selectors. Another differentiator of this kind of model is that they can take a large variety of data type as input, such as speeches, images, videos, text, and so on, and other data susceptible to being represented as vectors. So in chemistry, a widely acknowledged hypothesis is that properties or activities of chemicals are intrinsically determined by their molecular structure. So experiences in chemistry has shown that chemicals with similar structures usually have similar activities and properties, which is typically known as the similarity principle. The above hypothesis and experiences from the basis, the above hypothesis and experiences form the basis of QSAR's models. People interested in the history of and advances in the field of QSAR may consult excellent reviews elsewhere. A QSAR model is in its nature data driven, and in practice it's established from what we call a training set of chemicals. So the training set data contains principally two aspects of information of the chemicals. We have the endpoint property or the endpoint activity, aka it's the response that we are searching for, the response values, the Y, that are typically observed in a specific experiments. And two, we have the feeders, where M is the number of feeders, it's dimension of the feature space that quantitatively characterize the chemicals. So an arbitrary chemical, those can be represented as data point Y and X in the property activity feeder space. Mathematically, the established QSR can be expressed as a function f mapping x to y. The features of chemicals are directly or indirectly related to their molecular structure, typically being termed as the term descriptors. Descriptors in the field of QSAR are obtained via experimental observation or calculated based on the molecular structure, what we are going to see in when we are going to see the QSAR model, the QSAR toolbox. And the early QSAR models mostly adopted descriptors from experiment, including constant like the Hammett constant and octanol water partition coefficient, and so on. So, however, obtaining descriptor via experimental calibration can be mostly complicated, expensive, and comes with error, with inevitable errors, as computational chemistry and the cheminformatics developed descriptors based on global or local topology, connectivity of atoms, 3D structures, and electronic structure and chemicals of the chemicals can be calculated. So now let's take a look at the QSAR toolbox.
So the QSAR toolbox is a free software. It's a software application that supports reproducible and transparent chemical hazard assessments. It offers functionalities for retrieving experimental data, simulating metabolism, and profiling properties of chemicals. We have the ability first to add chemicals, even by their CAS number, by their chemical name, or by their structure. We can define the structure of the substance of the product that we are going to study, and it gives us the smile. after inputting um, our chemical, we can even calculate parameters, calculate the fingerprints, applying profiling or applying metabolism. So for metabolism and transformations, the assessment of metabolism and transformation products is a crucial step in chemical risk assessment. The use of toolbox to explore experimental metabolism. So we have here to enter a chemical first. It doesn't matter. And you can also use the toolbox to assess the consistency of a category and the starting point for read across justification. We can collect data from databases or collecting data from the analogs. So once we have built a consistent category, fill data gaps for our substances by using data from analogs, and classical read across or trend analysis can be used for this purpose. At the final point, after defining the endpoint toxicity, we can run the QSARs, and QSARs predictions are a cost and time effective way to it's a way to create supporting evidence for your assessment before going to analysis. So for low tier endpoints, QSAR evidence can even be used as standalone to fill data gaps. For those who are interested in QSARs, there is a bunch of videos on YouTube that explain every part of this software.